So let's finish up. So the next role for differentiation is what we call the chain rule. So chain rule is applicable for composite functions. So we'll give the statement and then give examples to illustrate how to find derivatives using this method. So if y is a function of u, and this u is a function of x, then the composite function f of g is a differentiable function of x. And we write dy dx dy dx is given by dy du times du dx. Or we can write the derivative of f of g of x is the same as f prime of g of x times g prime of x. So this is what we call the chain rule, applicable for composite functions. So what you do, you identify the u part of the function, you identify one part of the function, you let it to be u, and then so the function becomes a function of u. Then to get the dy dx, you find dy du, then multiply by du dx. So for example, find dy dx given y equals to x plus 3 power 10. So for those who don't know the chain rule, this would have been the same thing as multiplying x plus 10, x plus 3 by itself 10 times, then apply the power rule to each of the terms to get the derivative of this function y. But that is time consuming. And when we have more power, more than 10, with that structure, then you see that you'll have to do a lot of work, and at the end of the day, you may get some mistakes in your expansion. But the chain rule make work easier. So this is how you use it to get the derivative of this function. So this bracket, you fix it with the variable u. So you'll say let u be the bracket which is x plus 3, which means then by letting this bracket to be u, the function would be y equals to u power 10. Because of the contents of the bracket has been fixed to u. So y will be u power 10. So then now with these two functions, it implies du dx. So just differentiating this function using power rule, you get 1, and dy du using power rule will be 10 u power 9. So you have your du dx and you have your dy du. So by chain rule, dy dx is dy du times du dx. So which will be du dx is dy du is 10 u power 9. Du dx is 1. So 1 times 10 u power 9 just is 10 u power 9. So this will be 10 u power 9. But remember, u was our own creation. The original function was in terms of x. So therefore, replace that u by its expression in terms of x. So we'll have 10 into x plus 3, then power 9. And this will be our dy dx. Then example 2, y is given by x squared plus 1 power 3. So who can tell us the best choice for you in this case? X squared plus 1, correct. So we let u to be x squared plus 1, which implies y will now be u power 3. Then with this choice, what will be du dx? (2x), and then dy du 3u squared. This is just power rule. So therefore, by chain rule, dy dx is given by dy du times du dx. So dy du is the same as 3u squared. Du dx is the same as 2x. Now 3u squared times 2x will give us 6xu squared. But remember, u was our own creation, so replace it with the original expression for x. So this will be now 6x into x squared plus 1 squared. So this will be the final answer. Then can you try this? Y equals to 3x minus 2x squared power 3. Find dy dx given y is 3x minus 2x power 2 or 3 then. So what is the best choice for you in this case? Yeah, so what is in the bracket? So let u be 3x minus 2x squared. So which means y will be u cubed. So u power 3 or u cubed. So this implies du dx will be, yeah, so we'll have 3 minus 4x and dy du
squared.
3u squared, correct. So then by chain rule, dy dx is given by dy du times du dx. So what will be dy du is 3u squared, du dx is 3 minus 4x. Then which will be the same as 3. U alone is given by 3x minus 2x squared square. Then this is 3 minus 4x. So this will be the final solution. Then can you find dy dx when we have y is sine of kx, where k is a real number? So what will be the dy dx for this? So what is the best choice for you in this case? Orbe? K. So what should we fix as u in this problem?
Sine k.
Sine k. What is the base choice for you in this case?
U is equals to kx.
Correct. U equals to kx. So kx will be the best choice for you. So let U be kx. So that means y will be sine of u. So with this choice, what is du dx? Will be? Okay. And then dy du. Derivative of sine is cos u, correct. So therefore now, by chain rule, dy dx is dy du times du dx. So which will be cosine of u multiplied by k, but it's good manners to write k before cos u. But then remember u was not in the question, so the answer will be k cosine of kx. So can you try dy dx for cos of kx plus 4? Find dy dx if y is cos kx plus 4. That will give us correct. So the value for dy dx, if you work it correctly, should be negative k sine kx plus 4. Then can you work out the dy dx for y equals to e raised power kx? So what will be the best choice for you in this case? y equals to e raised power kx. So what will be the best choice for you? Kx. So we let u to be kx. So which means y will be e power u, correct. So then now calculate du dx. Okay, correct. And dy du. E power u, because when you differentiate exponential, it means the same thing, correct. So by chain rule, dy dx is dy du times du dx. So which will be dy du is e power u, du dx is k. So which is the same as k e power u. But you remember, u is our own creation. So you replace it with the correct value, in correct expression in x. So this will be the final answer. Now, if you get this one, then we can stop. Square root of 2x plus 3. Y equals root 2x plus 3. So what would be the best choice for you now? Well, square root is the same as power. Maybe let's do it. Let's just do it together so that you can stop. Square root is the same as power. A half, power half. So then you can write this one as 2x plus 3 raised power half. So then this let tell you that your best choice for you should be 2x plus 3. And so y will be u raised to a half, correct? So therefore now du dx will be 2, and then dy du Correct, a half u raised to negative a half. So then now we multiply them by chain rule. So by chain rule, dy dx is dy du times du dx. So which will be a half u power minus a half times du dx, which is 2. So 2.5 cancels out. So this just leaves us with u power negative a half. So which will give us 2x plus 3, then raised power minus a half. So if you want to write this one as a square root, it will be? So then 1 over square root of 2x plus 3. So remember, this is the same thing as saying 1 over then 2x plus 3 raised per half. So raised per half is the same as square root. So this is what you'll have. I hope if we stop there, it's okay. Or should we give more examples? Or you have understood what is happening? Should we give more examples on chain rule? Or you have understood you can now apply it to more other examples? Should we give more examples of that? You are okay? You can apply to the other examples? Other problems are the same? Silence means we continue. Okay. So what if we have y equals to sine cosine of x? Sine of cosine of x. So what is the best choice for you in that case? Cosine of x, correct? So here you let u be cosine of x. So which means y will be sine of u. So then du dx minus sine x, and dy du cosine of u, correct? So by chain rule, dy dx is dy du times du dx. So that dy du is cosine of x, cosine of u. Du dx is negative sine u, sine x. So which you can write this one as negative sine x cosine of u. But you remember, u is our own creation. So the answer will be negative sine x cosine of u, which was cos x. So this will be the final answer. I hope that is enough now for today. Okay. Yeah. So I'm sharing the notes and the recordings, then ensure that you update your work before we meet next. Because what we are doing today is what we'll be building on next time we meet. So ensure that you update your work before then. Sawa. Yeah, sawa. Have a good day. Okay.